Hello friends, greetings to all. I Professor Darshan Thakur from Terna Engineering College Dharashiv welcomes you on my YouTube channel for this subject head network theory. So friends, as far as our today's session is concerned, so we will try to discuss the most important circuit analysis technique whose name is nothing but what? The superposition theorem. So one basic question arises in our mind ki, why we are going for the superposition theorem means ultimately we need to understand the objective behind the superposition theorem. So in case of electrical engineering, whenever it is required to analyze the given network means whenever it is required to determine the ohmic drop or the current flowing through any particular element, at that time the superposition theorem technique is being taken into account. So first of all we need to understand the statement of the superposition theorem. So the statement of that superposition theorem states that it is very simple to understand ki in any linear bilateral network. A linear bilateral network means what? The special kind of network or the circuit whose parameter or the properties will remain same even though we are changing the direction of applied voltage or current. So this is how this linear bilateral network is being called. So in case of any linear bilateral network, whenever it is required to determine the current flowing through any particular branch, so at that time the current flowing through that particular branch is an algebraic sum of current when all energy sources are acting independently alone. Means the basic requirement for the superposition theorem is to have the multiple number of energy sources that we need to understand, right? So there are two types of energy sources, either we can have the voltage source or current source. As far as this given network is concerned, or with the help of this very simple network, we will try to determine the working principle of the superposition theorem. So here the objective is to determine current flowing through this 20 ohm of resistor. So according to the statement of superposition theorem, the current flowing through this 20 ohm of resistor is an algebraic sum of current due to this 20 volt of battery and due to this 4 ampere of current source when they are acting independently alone. So that is the logic behind the superposition theorem, which is very simple to understand. So the basic requirement for the superposition theorem is nothing but we should have the multiple number of energy sources. As we are having two different types of energy sources, voltage source or current source. Again, apart from this, furtherly this energy source can be classified into the dependent energy source or the independent energy source. That is a very big area of discussion. Let us not waste our time in that. So we will try to concentrate on this numerical or on this given network in which we need to determine the current flowing through this 20 ohm of resistor by using superposition theorem. So as already we had discussed the statement of superposition theorem, now it's time to apply the superposition theorem on this given network. So there are certain design rules that we need to understand. So let us quickly go through the design rules for the superposition theorem or the steps involved in case of the superposition theorem. So here objective is to determine current flowing through this 20 ohm of resistor. So in that first step we need to consider this 20 volt of battery. By considering this 20 volt of battery, how that circuit will look like? This is 20 volt of battery. This is 5 ohm of resistor. This is 10 ohm of resistor. Again, this 10 ohm of resistor. And this is our target resistor of 20 ohm. This is 10 ohm of resistor. And while considering the 20 volt of battery, one more important thing that we need to understand when we are considering the voltage source in that given circuit or in that given network, at the same time how to treat the remaining energy sources, right? So as we are having only two energy sources, one is voltage source and another is nothing but what? The current source. Okay friends, so while considering this 20 volt of battery, what we need to do, as there are two energy source, so this current source of 4 ampere that can be treated as a open circuit element. right? While considering this voltage source, we need to consider this current source can be treated as an open circuit element. Means it has nothing to do with this given network now. Means virtually it is being removed. So this is how that circuit will look like, right? Furtherly, our area of interest is to determine the current flowing through this 20 ohm of resistor. So according to superposition theorem, when we are supposed to consider this 20 volt of battery, so at that time this 4 ampere of current source is no more with us. So this is how that circuit will look like, right? And at this particular stage, there are multiple techniques by which we can determine the current flowing through this 20 ohm of resistor. If you observe this circuit from loop analysis point of view, so there are two identical loops we are having with us. This will be the current flowing through first loop, this will be the current flowing through second loop, this will be I1 and I2, right? So here I2 is nothing but what? The current flowing through this 20 ohm of resistor. So by applying the Kirchhoff voltage law to the first loop as well as second loop, we are having two different kinds of equations. After solving these two equations, we are getting I1 and I2, right? So this will be the first probable technique in order to determine the current flowing through this target resistor of 20 ohm. Okay. Then after that, the second probable technique is nothing but what? By using this node analysis also, we can determine the current flowing through this 20 ohm of resistor, which will be quite simple as compared to the loop analysis technique, right? So here again one more thing we need to understand why this nodal analysis is most of the time is being preferred over this loop analysis technique. The reason behind that, each time we are reducing the number of iterations or the number of equations are being minimized in case of this nodal analysis technique as compared to loop analysis. Okay. In case of loop analysis technique, there will be two identical equations, but when we observe this circuit from node analysis point of view, so we are coming on to this conclusion this will be the main node which is present in that network. So node is nothing but what? The point at which multiple number of branches are interconnected to each other. And one more node we are having with us, obviously ground node. So there are two identical nodes, one is dummy node and one is nothing but what? Main node, whose potential is what? If suppose we are considering the potential of this node as a V suffix A, means the name given to that node is nothing but what? Capital A, and the potential which is present at that node is nothing but what? V suffix A. Okay. Then after that, according to nodal analysis, when we are coming on to this conclusion there are two nodes. Out of that two nodes, one is dummy node and one is nothing but what? Main node, whose potential is nothing but what? V suffix A. Then after that, we need to apply the Kirchhoff current law. So for that purpose, we need to recall the basic strategy of this Kirchhoff current law. This Kirchhoff current law says that incoming currents are equals to outgoing current, or summation of incoming currents equals to summation of outgoing current. Then after that, we need to assume that there are how many branches. What we need to assume, the direction of current belongs to that branches. So as there are three branches, first, second and third. So there will be three branch currents, I1, I2 and I3. Now it's time to assume the direction of I1, I2 and I3. I1, I2 and I3. So while considering their current direction, we need to consider whether these currents are outgoing from this node or incoming to that node. So most of the time, these branch currents are being considered as outgoing current. So this will be the first branch current I1, this will be the second branch current I2, and this will be the third branch current I3. Then after that, what we need to do, according to this Kirchhoff current law, one by one we need to define I1, I2 and I3. So here I will write I1, I2 and I3. Now I1 is nothing but what? The I1 is nothing but current flowing through this branch in which we are having this 5 ohm of resistor. So how that branch is connected from that node? This is the potential of node VA, and this is 5 ohm of resistor, this is 20 volt of battery, and this is ground node. Okay. The direction of current is outgoing from this node, from A node to the dummy node or the ground node. So according to that Ohm's law, I equals to what? V by R, right? So here The potential of this node is nothing but what? V suffix A. One more potential we are having in that branch. The branch is associated in between VA and this ground node. In between these two nodes, there is one resistor of 5 ohm and there is one battery of 20 volt, and these are the polarity of this battery, positive and negative. Okay. So the direction of current is outgoing, means we are going from positive to the negative plane. That's why the potential of this 20 volt battery will be minus. So it will become VA minus 20 divided by the desired value of current is nothing but what? 5. How this statement is being written? R equals to V by R. We are supposed to define the current flowing through this branch, whose name is nothing but what? I suffix 1. In same way, we need to consider this I2 fellow. I2 is nothing but what? The current flowing through this 10 ohm of resistor. How it is connected? This is main node VA, this 10 ohm of resistor, and this is ground node. How it is considered? Outgoing, I2. So according to that Ohm's law, V by R. So VA upon the value of resistance is nothing but what? 10. So this is how I2 is being tabulated. Now lastly I3. I3 is nothing but what? The current flowing through this third branch. How it is connected? This is 10 ohm of resistor, 20 ohm of resistor, and this is ground node, 10, 20, and the direction of current is outgoing. The name of that current is nothing but what? I3. So I3 equals to what? Again according to that Ohm's law, V by R. So VA, these two resistors are connected in series form, so VA by 30. So these three equations we are getting belongs to I1, I2 and I3. Then according to that Kirchhoff current law, which says that summation of incoming currents equals to summation of outgoing currents. So here we are having these three incoming currents. We don't have any outgoing current. So we need to add the mathematical expression of I1, I2 and I3. And after going through that simple mathematical simplification, we will try to determine the current flowing through this 20 ohm of resistor due to this 20 volt of battery. So accordingly, these three statements are being added because Kirchhoff current law says that I1 plus I2 plus I3 equals to 0. We don't have any outgoing currents. So expression for I1 is VA minus 20 upon 5 plus I2 is VA by 10 plus I3 is VA by 30 equals to 0. Our aim is to determine the current flowing through this 20 ohm of resistor by considering this 20 volt of battery. When this 20 volt of battery is being considered, this 4 ampere current source is no more with us. So that existing circuit is to be analyzed with the help of nodal analysis technique. We are coming on to this conclusion that there will be one main node and one dummy node. So we need to apply the Kirchhoff current law at that main node. As a result of this, summation of incoming current is equals to summation of outgoing current. Okay. Now we don't have any incoming currents and there are three outgoing currents which are nothing but what? I1, I2, I3 equals to 0 because we don't have any incoming currents. And now there are certain mathematical ways by which we can realize this expression. So for that purpose we can consider this LCM as a 30, or we need to collect the terms belongs to VA. It is 1 by 5 plus 1 by 10 plus 1 by 30. Remaining term is nothing but what? Minus 20 by 5 is being shifted to the right hand side of this assignment operator. As a result of shifting, it will become plus 20 by 5. Okay. So it is 1 by 5, obviously 0.2, 1 by 10, 0.1, 1 upon 30, 0.03 times of VA equals to 5 4s are 20 equals to 4. So the summation of these three terms will become 0.33 times of VA equals to 4. So VA equals to 4 upon this 0.33 times of VA. Okay, 0.33. So VA equals to approximately 12.12 volt, which is always measured in terms of few volt, right? So this is nothing but what? The corresponding value of this node potential that can be called it as a V suffix A. Our area of interest is to determine this I3 fellow. I3 equals to what? VA upon 30. So here VA is nothing but what? 12.1212 upon 30. So approximately the value which is coming out of from this division operation is nothing but what? 0.4 ampere, right? So 0.4 ampere is nothing but current flowing through this 20 ohm of resistor due to this 20 volt of battery by virtually disconnecting this 4 ampere of current source. Now it is very important for we people to understand how this 0.4 ampere current flows through this 20 ohm of resistor. As this 20 ohm of resistor is connected in vertical arm, so there are two probabilities, either top to bottom or bottom to top. If it is connected in a horizontal arm, so left to right or right to left. These are the two probabilities, right? So according to the conventional direction of current, which always flows opposite to the flow of electrons, means the conventional current always flows from positive to negative terminal. So this current will flow like this through this 20 ohm of resistor. Means this current will flow through this 20 ohm of resistance from top to bottom. So this is the direction of current through this 20 ohm of resistor due to this 20 volt of battery. 0.4 ampere top to bottom. So this is the half part. So in that remaining part, we will try to consider this 4 ampere of current source. Okay friends, after tabulating the current flowing through this 20 ohm of resistor due to this 20 volt of battery is 0.4 ampere. Then after that it's time to consider the second energy source which is present in that network. The second energy source of this current ampere, whose value is nothing but what? 4 ampere. So in that second step, what we need to do, we need to consider the current source of 4 ampere, and while considering this 4 ampere of current source, that is most important for we people to understand, the remaining energy source is nothing but what? Voltage source. So while considering this current source, that voltage source can be treated as a short circuited element. So accordingly, how that circuit will look like? Now this 20 volt of battery can be treated as a short circuit element like this. Remaining circuit as it is. This is 5 ohm of resistor. This is 10 ohm of resistor. Again this is 10 ohm of resistor. 10, 5, here also 10. And this is our target resistor is of 20 ohm. 20 ohm, and now we need to connect this current source of 4 ampere, right? So this is how that circuit will look like in that step number 2 to determine current flowing through this 20 ohm of resistor due to this 4 ampere current source. Okay. Now again there are multiple number of techniques by which we can determine this current flowing through this 20 ohm of resistor by using mesh analysis, nodal analysis, or apart from this mesh or node analysis. Now it is very much better for we people to use the circuit resolving technique. Circuit resolving technique means what? If we start to resolve the circuit from this left hand side, so at that time we are coming on to this conclusion that these two resistors are connected in shunt form, right? These are connected in parallel form. So we need to determine the parallel combination of these two resistors. So as a result of this, what we need to do? R1 into R2 divided by R1 plus R2. So which two resistors are connected in shunt form? This 5 ohm of resistor and this 10 ohm of resistor. So their parallel combination will become what? 5 into 10 divided by 50. So 10 5s are 50 divided by 50. Okay. Then 15 3s are 45, so 3.33. So how that circuit will look like? This is the resistance of 3.33 ohm, the parallel combination. Then remaining resistor is of 10 ohm. This is our target resistor of 20 ohm, and this is current source of 4 ampere. So this is how that circuit will look like. Then after that, these two resistors are connected in series form, right? So again, this 10 plus 3.33, it will become what? 13.33. So this is how that circuit will look like. So in that last step, we are coming on to this conclusion key. Due to this 4 ampere of current source, the current flowing through this 20 ohm of resistor, that might be called it as a I20 double dash. I20 single dash is nothing but what? Current flowing through this 20 ohm of resistor due to this 20 volt of battery, which is 0.4 ampere. Now it's time to determine the current flowing through this 20 ohm of resistor due to this 4 ampere of current source. So at that time this voltage source is being short circuited. Then after that, by using circuit resolving technique, these two resistors are connected in shunt form. Their parallel combination equals to 13.33. And now at this particular stage, as we know, this 4 ampere current source will get divided in between these two branches. Means these two branches are connected in shunt form. So always there will be a division of current at that particular node. So according to the current division rule, we need to determine this I20 of double dash. This current division rule says that if we are having such type of circuit, this is 20 battery, this is R1 and this is nothing but what? R2. Okay. Meanwhile, I will rub this previous network in order to understand the working of this current division rule. Meanwhile, I will write here I20 of single dash is 0.4 ampere. So, according to this current division rule, whenever we are having such type of network, this is the voltage source and these two resistors are connected in shunt form. This is R1 and R2 and these are the I1 and I2. So the same concept is being used here. Here capital I is nothing but what? Total current due to this battery of V volts. So whenever it is required to determine this I1 or I2 according to this current division rule, which says that up to this node total current is nothing but what? Capital I multiplied by resistance in its opposite arm, that is nothing but what? R2 divided by the sum of these two resistances, R1 plus R2. The same thing is used for I2. The only difference is what? Here the total current multiplied by R1, resistance in its opposite arm is R1 divided by the sum of these two resistances, R1 plus R2. So the same concept we need to use here. I20 of double dash equals to total current 4 ampere multiplied by resistance in opposite arm 13.33 divided by this R1 plus R2, means this approximately it will become 33.33. So if we tabulate this division, so which will approximately equals to 1.60 ampere or 1.5958, like something like this. So rounded off value will be 1.60 ampere, right? Then how this 1.60 ampere current flows through this 20 ohm of resistor? See, this is the direction of current. So this is upper terminal is positive, lower terminal is negative. So the conventional direction of current is always from positive to negative. So again in down, from this top terminal to this bottom terminal, this will be the desired flow of current, means top to bottom. So this 1.60 ampere flows through this 20 ohm of resistor, that can be treated as a I20 of double dash due to this 4 ampere of current source equals to 1.60 ampere. Then after that our aim is to what? Our aim is to determine the current flowing through this 20 ohm of resistor according to the superposition theorem. Now we need to recall the statement for that superposition theorem is nothing but what? In any linear bilateral network, current flowing through this particular element is an algebraic sum of current when multiple number of energy sources are acting alone. So due to this 20 volt of battery, current flowing through this 20 ohm of resistor is 0.4 ampere top to bottom. Similarly, algebraic sum means what? Either these currents are being added with each other or they are subtracted with each other. If their current directions are opposite to each other, at that time these are being subtracted. If the current directions are similar, so they are being added with each other, which will happen in this case particularly. I20 of double dash 1.60 ampere top to bottom. So finally I20 is nothing but what? I20 of single dash plus I20 of double dash. I20 of single dash is how much? 0.4 ampere and I20 of double dash is 1.60. So total current flowing through this 20 ohm of resistor according to the superposition theorem is of 2 ampere. So in this way, this is the probable technique by which we can analyze the given circuit by using the superposition theorem. So I just hope you can understand all these things which we have discussed in this lecture. Thank you.